Name and major.
My name is Hafer-Greene. I'm in the electronics program here at Penn College.
My name is Sabin, Jr. I'm in the electronics and computer engineering technology with the robotics and automation emphasis major.
Awesome. And?
My name is Joshua Herron, and I'm in the robotics and automation.
Okay, great. So what you got here?
Well, the temperature was reached on our little resistor setup we have here. We're trying to do a semiconductor manufacturing simulation, small scale. This block is simulating a pod of semiconductor wafers. Since we don't have an endpoint or a destination here, we just have it come back. Once it hits this destination, the robot picks it up, and the only live destination that we have are these two resistors that are measured by this RTD sensor with this thermocoupler, and we have it set right here with live temperature in degrees Celsius. Right now it's at 34 degrees Celsius. The robot just sent up an output to turn on this heater relay to heat up these resistors, because their power rating is only quarter watt, but they're 1 ohm resistors, and we're sending 0.5 volts through them, and they're in a parallel circuit. Once it hits 50 degrees Celsius, it goes in range, and the robot knows to pick it up. This could simulate like a semiconductor curing stage, or yeah, like a temperature stress test. And then it goes to the second destination, which, since we don't have one of those, we just have it come back and repeat the process.
Look at that.
As our first project in this program, we wanted to do everything. We wanted to use every component we've worked with so far this semester. So it gave us the idea behind building this automation circuit.
This pretty much simulates everything that we learned throughout the semester. We have infrared sensors here because we're not using a capacitive or inductive material. We have all the way back to Gotcho and Carl's class, analog resistors. We're using an analog module and a thermocoupler that we weren't even taught yet. We have relays out the wazoo, which no one really likes relays, but we don't care because we're bosses. We got our power supply. We have our PLC normally open, normally closed, our e-stop. Here's our PLC program with a function for the thermocoupler that we weren't even taught, but Hafer-Greene figured it out. And it's just a basic function with a, here's next semester's lab. We just stole it from Moser. And it's just a basic slope intercept function with a multiply and divide and a comparator for setting off our in range.
And the robot just completed a full cycle, so.
And yeah, here's our.
The program is now repeating.
Here's our. Here's Josh's 70,000 step program for his robot, and it's running like a boss. So we pretty much win at everything.
It's got style too.
Yeah, and right when it goes to pick up the semiconductor pod from conveyor belt number 2, it has a pretty mean flick of the wrist. And we have our post-it notes here for our sweaty robot palms that stick to the semiconductor. The robot placed it on the heater, so it's going to heat it up again. Here's the live temperature in degrees Celsius, 44 degrees Celsius. 77 degrees Celsius, comparing it here, communicating with the robot through this dry input.
Yep. So
there it goes.
It's in temperature
So it'll
range,
pick it up, is temperature reach. So put it where it needs to go for temperature reach.
Alright, and this is it.
Everything is controlled with PLCs and ladder logic. Everything was programmed with ladder logic from the basic fundamentals.
And once it gets back from here, it'll tell the robot to pick it back up. And since these conveyor belts are so narrow, Josh programmed it to do a pretty good flick of the wrist right here.
Look at
You
that.
didn't see that coming.
Wow.
Bang bang, old block, 300. Do what it do.
You would expect to see this something in an assembly line of a microchip fabrication plant,
Right.
where they're testing their chips right after they were manufactured to pass the quality control check.
Right.
And that's what we were trying to do here.
Okay, awesome. Great project. Pretty cool.